Let's discuss further. This is fx equal x minus 1 x minus 2. This is a cubic graph. So you can see the graph here. Minus 4 to 4 and minus 4 to 4 axis and y axis, the domain and the range, and we'll learn translation. We do a translation on x-axis, plus 2. So this is what will happen. Instead of we put x plus 2. Now what kind of graph you expect, and we'll see that's the graph. So I'm going to do that change on the graph. Now you can see the blue one is the original graph, which is x minus 1 x minus 2, and if x plus 2, what will happen? It's a translation. We can see that the graph is moved to 2 units, which is red one. 0 is moved to minus 2, the root, and the root minus 1 is moved to the 1 is moved to minus 1 and 2 is moved to 0. Actually, let me make 3 this one, then now it's very clear now. Earlier 0, so shifted by 3 unit, that is minus 3, and minus 1 shifted by 3 units to left, minus 2, and 2 shifted by 3 units, now it is minus 1. You can see that the rules. Now let's discuss what will happen if it is minus 3. So it's a translation again. The graph is moving to yeah, you can guess, and let's see the translation. The graph is translated to or shifted by 3 units to right. Now I have to expand the x region, so let me expand it. Now you can see the graph, and so this is a translation along x-axis. Now we'll discuss the stretch. Now it is back to the y equal fx graph. What will happen y equal f2x? What kind of graph you expect? So it's going to be a stretch, or you can say squeeze by a scalar factor of half. So let's see the graph. So this is the graph. You can see that the blue graph is the original graph, and is squeezed by squeezed, and the scalar factor is half. All the x values turn into half. So 0 root is at 0. 0 divided by 2 is 0. Then root 1 divided by 2 is become half, and 2 divided by 2 is 1. So you can see now on the red graph the roots become 0, half, and 1. In the blue graph it was 0, 1, and 2. Now it was squeezed to 0, 1, 0, half, and 1. So this is fx 2x. So what will happen if it is half x? So we'll do the relevant change of 8.5. So you can see the graph now. The blue is the original one, red is the translated stretch one. By it is half, multiplied by half mean half x mean the scalar factor is 2. So all the x values multiply by 2. You can see that 0 is still the 0 because 0 times 2 is 0. In the blue graph, root 1 times 2 is 2. You can see now in the red graph that 2, and 2 times 2 is 4. So this is along x-axis. And let's discuss on y-axis now. Let me bring the graph back to normal. And this is y equal fx. Then plus 2. We are expecting to shift the graph by 2 units up. So let's see that. I typed in the wrong place. It gave a different graph. Now you can see that the blue graph is the original graph, and the red graph is the shifted graph. If you look at the original graph fx, the root are 0. If you look at the 0 root, now it is at 2, 0. So the graph is, all the y values is shifted by 2 units so up. And let's discuss minus 2. Then let me change it. Now you can see the red graph, the root is shifted down to minus 2, 0. The blue one is the original graph as usual. And so this is a translation on y-axis, and we'll see that 2fx. So it means all the value of y multiplied by 2. So we'll see in the graph 2 times. You can see, okay, I'll go back to the original graph first. Now this is the original graph, and now you can see the roots are still the same, but all the y values is multiplied by 2. The blue grass is the original one. So let's say this is 25. Okay, 10x. Then let's see the difference. So this is if it is 10. You can see the maximum is yellow graph maximum, blue graph maximum, and red graph maximum. This is the stretch one. And then let's discuss, this is what will happen if this is half. So now you can think about what kind of now you can see the peak maximum is half and the minimum also half. So this is along the y-axis. Now let's discuss what will happen mod x. In the previous section we discussed mod f mod x. What kind of graphs we are expecting. Um, so the blue graph is the original graph, and now you can see in this graph when you put f mod x, uh, it will give a mirror reflection. The red part is the mod graph, so it is a mirror red part, and you can see the marginally a W shape, so that shape is the graph for mod x. And then we'll discuss actually let me delete this part, then it is a bit clear. Original graph. Um, so this is the mod x graph, the actual graph, and then we'll discuss I need to go back to the original graph. Okay, let me try now. Yeah, now this is graph is fine. So this is the original graph, and we'll put mod down mod fx. So you can think about what kind of graph you are going to expect. So mod fx mean the command is given to chop all the negative values of the graph. Um, clear. Let me try. Yes. Now you can see that all the um, when you look at y value of blue graph, now then look at the negative values, and you can see that negative values, all negative values turn into positive values. If I delete the original graph so it is clear, uh, so this is the y equal mod fx graph. So this is, now you can, I hope that you have kind of idea about the translation all on x-axis, y-axis, and the mod value. When we apply mod value, what kind of graph, what kind of changes we can expect. We'll move to the example 20 in the next session.